Hi, my name is Kyle, and this is our second video for the definition of a derivative. We're going to do something a little more challenging today, where we do f of x equals the square root of x minus 4. This is a standard problem that you may see on an exam. If I was a professor or teacher, this is how I would do it, because it incorporates what you know about a limit in the algebra that you will have to do. Which, once you see what is going on, isn't that tough, but we will work through it. This is the form we're going to use for the derivative. Our f of x, or f prime of x, equals our limit as h goes to 0, h being the little increment of x that we use, of f of x plus h minus your function f of x all over h, which is basically a delta y over delta x, a slope. And you'll see that when we get to tangent lines, is we'll find the slope at a certain point and plug it back into some point to find some equation of the line. Write this down if you need it, and if you don't, we'll get started. I'll erase it and we'll get started. What we know is we have the limit, and of course this is f prime of x equals the limit. Don't forget that. As h goes to 0 of x plus h minus 4, you can put this in parentheses if you would like, to denote that little change in x. We have the square root of that. Minus the square root of our function. So we have x minus 4, of course the square root of that whole thing. All of this is over h, of course. So here comes the tricky part. Since I have limited board space, I may have to shrink it down a little bit to get it to fit it all on here. But what we see is there's not a whole lot we can do here. If we plug the limit in, we'll get something over 0, where, well, technically we'll get 0 over 0, which is indeterminate. And since it's indeterminate, it makes no sense in the limit form. So, if we know anything about a limit, we know if we multiply something, we can always multiply something by a factor of 1, and it can change the look of the function, but it won't change the function itself. So what do we multiply here? And we think, well, we can multiply the conjugate, which is basically this whole thing, but it's plus this little function here instead of minus to the top and bottom, or numerator and denominator. And what we get is the limit as h goes to 0 of the square root of x plus h minus 4 minus x minus 4 all over h times, and I use a little dot for my multiplication because of dot product and cross product, and I'm just used to it, times x plus h minus 4 plus this, plus the square root of x minus 4. Of course, this is all the square root of x plus h minus 4. I'm going to give it parentheses, so we know to multiply the whole thing. Of course, since we're multiplying by 1, we're multiplying by this over this, because anything over anything equals 1. Thus, if we multiply x plus h minus 4 plus square root of x minus 4, of course this is square root again, we're multiplying by 1. Well, when we distribute this through, we'll just multiply this toward the h, and we'll take care of that. We're going to leave the h outside because, consequently, like I told you in the last video, in the end, what you need is an h on the top and an h on bottom that you can cancel through multiplicative means. And so we're going to leave that outside to see what we can come up with. So we have the limit as h goes to 0 of if you FOIL this, because you're going to have to FOIL this whole thing, and we'll do something a little different for the FOIL on this. I have it worked out, and it becomes x plus h minus 4 minus x plus 4 over h times this. So it's x plus h minus 4 minus x plus 4 all over h times the square root of x plus h minus 4 plus the square root of x minus 4. Well, you're probably wondering how I got that, and if you FOIL it, you'll find out how I did. But I devised a little way for something so that we can multiply this for something a little more complex. And it's tedious, but it'll make sure you get the right answer. It's a quick check, actually. We can stack and multiply this whole part. So what we can do is x plus h minus 4, that's the square root of, minus the square root, and I'm stacking and multiplying this denominator times this denominator, times x minus 4, and this is just a quick check, times x plus h minus 4, minus, plus, not minus, plus x minus 4. Alright? Now, just like numerical multiplication, eight times 9 is 2, 72. So we have a 7 there. 8 times 7 is 56, plus 7 is 63. That becomes a 0. We move across here. So 7 times 9 is 63. 7 times 7 is 49, plus 6 is 55. You can add these together and you have 2, 6, 11, well, not 11, but 1. That 1, so 61, 62. And let me check that on a calculator, actually, to make sure I did it right. I use these fancy little things. And I did. But see, that's foolproof. It's guaranteed. So what we can do here is, this times this, we'll end up with the square root of something times the square root of something will give you something whole. Or without a square root to the 1 power. So that's negative x, it's actually negative x plus 4, but we're going to leave it here, times, and then, we move over here and we get x, the square root of x plus h minus 4 times the square root of x minus 4. And we're going to leave that for now because when you multiply this one and this one, what you get is x plus h minus 4. Of course, that's the square root. Denote these with parentheses, and this is getting a little clustered, so I'll erase this. Times, of course this is the negative because you're multiplying a positive by a negative, square root of x minus 4, times, or plus, that times that, and it'll end up being, you know, the square root of x plus h minus 4 times the square root of x plus h minus 4 is nothing but x plus h minus 4. Well, as we sum this bottom portion and this top portion, these two will cancel out because one's positive and one's negative, and they'll sum up to 0. So what we have, right, is x plus h minus 4 minus x plus 4. That's the same thing we got down here. I just wanted to show that so you could see where I got it. I'm gonna leave this up. I'm gonna erase that, but I'm gonna leave that part up for now. And what we can see here is if we can combine like terms here, positive x and negative x, that becomes 0, and a negative 4 and a positive 4 becomes 0. And what you are left with, and now I'm going to erase this. Hopefully you've had enough time to copy it down and just push rewind on the video, if you need it. I don't think this is going to be a specific problem for somebody, but if it is, well, you kill two birds, I guess. What we'll end up with is the limit as h goes to 0 of h over h times the square root of x plus h minus 4 plus x minus 4. And what we can see is we can cancel those off. Like I said, if we get to a point in the problem where we can cancel an h in the numerator, or denominator and h in the numerator, as a factor of 1, we're doing something right. So now this becomes the limit, and always write your limit, as h goes to 0 of 1 over square root of x plus h minus 4 plus the square root of x minus 4. Now we can evaluate our limit and see what we get. And once we evaluate our limit, we get 1 over, this goes to 0 because as h goes to 0, this plus h will go to 0 because you just plug in your 0. The square root of x minus 4 plus the square root of x minus 4, which will equal 1/2 the square root of x minus 4. And there's your answer. We can quickly check this by a rule called the chain rule, where you let f of x, or it'll end up being f of u, where u equals x minus 4. Substitution. We're taking some variable and substituting it in with some singular variable because then it becomes easy. Of u to the 1/2. Well, we always have to, with the chain rule, we have to multiply the derivative of u. So f prime of u becomes u prime times, u itself. So when we do u prime, it'll become 1/2 u to the negative 1/2, and I'll just move it down here. The simple algebra rule. So that's pretty simple. And we'll run that later. But there's your answer. And of course, once you get your u value, you substitute what your u is once you get your derivative. So here's your answer. Any questions regarding this or integrals, which I need to start actually because I forgot it's later in the semester. I'm way past calculus 1. Integration by parts, I'll start in mid-May for a summer session. Trigonometric integration, differential equations, any of that. Physics, I'll get on physics, some Newtonian mechanics and some electricity and magnetism. And as the summer progresses, some quantum mechanics, some chemistry, kinetics, equilibrium, some simple stuff from Chem 1. I'll do that sort of stuff. Just let me know if you have specific problems, and I'll be more than happy to do vision for you. Thank you.